Hello, and thank you for having me today. So my name is Clément. I'm working at Red Hat, mostly on the Quarkus project, but I'm doing a lot of reactive things too. But today I'm not going to talk too much about reactive. Today I'm going to explain how Quarkus give you a lot more possibilities to build your microservices, because microservices goes well beyond HTTP. But first, what's Quarkus? So Quarkus is a cloud-native stack to write Java and Kotlin application. Java itself, as of today, is not really cloud-native in the sense that Java is 25 years old, and 25 years ago, the world was completely different. Your Java application has access to the whole set of resources of your mainframe or big machine, so can use all the memories, all the CPUs, and everything was fine. And you was restarting your process every 6 months, maybe 1 year. So it was very, very long running processes. Today, things are completely different. You are deploying on the cloud, on containers, on Kubernetes or whatever. You restart your application way more, and especially if you're on Kube or in containers, you must share the resources with your sibling containers. So you must use the resources efficiently. When we started Quarkus, we had this idea of microservices and serverless, two domains where Java is challenged a lot by different languages such as Node, or JavaScript with Node, or Rust or Go, but also serverless. And when we mention that, we say, well, actually what we are building is a stack to build distributed systems, because today most of the systems we are building are distributed systems, in the sense that as soon as you interact with a database, another microservice, remote API, whatever, you are building a distributed systems. One thing what is sure when you are dealing with a distributed system is that at some point it's going to fail. Whatever you do, failures are part of the game, and you need to embrace those failures. So with Quarkus, we try to provide all the tools you need to build better distributed systems, to build them more easily, and that's what we are going to see today. So we are going to build a few microservices using HTTP and REST, so the base, also databases, gRPC, GraphQL, Kafka, and well, for today it's just this, but as you can see on this slide, Quarkus can do a lot more than this. So how does Quarkus enable all those features? It has two principles, build time principle and a reactive core. So to understand the build time principle, you need to understand how regular framework starts. When you start your framework with Java, you do Maven package, Gradle build, and you get a file jar, a WAR file, whatever, and then you start it. At runtime, it will start by locating the some configuration. Can be XML, so you need an XML parser or something like that. Then it will do a class path scanning to find all your annotations. It will also try to load classes to toggle on and off features. Then for each framework, it will build its own configuration, and finally, it will start the pools, threads, sockets, and so on. So Quarkus does the same thing before. At build time, we will read part of the configuration. At build time, we will do the class path scanning and check classes that are available and not available. And for each framework, we will deduce the set of instructions that can be infused inside the package to do everything you need. So if you have entities, then we can say hibernate.add entity. If you have beans, then we can do the build time injection and so on. So at runtime, we are much, much faster to start because, well, we did less, a lot less. It has also a second big impact. It reduces the amount of memory you need. Why? Because we don't have to load all the classes. This is done at build time to find the annotations, to use the XML parsers and so on. So you are saving a lot of resources, a lot of memory thanks to this. You may have heard that Quarkus is also able to build native executable. This is actually a side effect of this build time principle. To do that, Quarkus relies on the GraalVM native compiler, which, as any serious compilers, need at least 25 arguments to create your native executable. So what I call native executable, it will be the same output you will have with C or Rust or Go. So it's really something very small that start very fast and use really a lot less memory than the JVM version. So what we do is that in Quarkus, at build time, we have enough metadata on your application, on your class, on the frameworks to compute this very, very large command line that is required to build your optimized native image. So why optimized? It's because today, with the progress of GraalVM, you can probably handle most of the Java program. However, if your executable will require as much memory as your JVM version, that doesn't make sense. So we don't do any compromise in Quarkus. We really want something very slim, very optimized for your native executable. So we don't use any fallbacks. So now I would like to talk about the second part of Quarkus, the reactive core. So we are building distributed systems on microservices. We need to handle IOs, so inputs, outputs. Recently, actually not so recently, but the operating systems have provided mechanism to handle IOs a lot more efficiently than before. So the thing is, it's since the the early 90s, the operating system provide mechanism for that, such as select, epoll, and the latest, which is IO uring. So at the operating system level, we have all those mechanisms that can handle lots of IOs very, very efficiently, but we need our frameworks to leverage those mechanisms. And that's what we do in Quarkus. We have a reactive core, which is based on Vertex and Netty. And on top of that, we have a few IO threads. And then we have the extension and the application code that can leverage this mechanism. So, but how was that working before? So when we start reactive, we need to understand what was the previous model. The previous model is named imperative. So with the imperative execution model, you get an HTTP request and you associate a thread, a worker thread that will handle this request from the beginning to the end until it's flushed inside the HTTP response. You start the processing, and at some point, because you do distributed system or microservices, you get blocked. You need to call a database, you need to call another service, whatever. So because of that model, you need to wait until the response comes back. So if you want to handle multiple requests at the same time, you need to have multiple threads. Each thread is 1 megabyte of memory. And remember what I said about Kubernetes and containers, you need to use the resources efficiently. Every megabyte you use is a megabyte that your sibling containers can't use. So this is definitely not efficient, and that actually doesn't scale because your amount of concurrency is limited by the number of worker threads. Also, if you are doing a large enough systems, what will happen is that all your threads are going to stay blocked, waiting for a poor system that you are calling or hammering, and because the system gets slow, you don't make any progress. On the other side, the reactive execution model use a few amount of threads named IO threads or event loops, and then we receive a request. This request starts to be processed on one of these threads, and as soon as it can't make progress because it needs to call the database or the service, it will schedule this IO and pass a continuation. A continuation is a block of code that will be called when the IO completes. The thread is released, and the same thread can immediately start processing a second request. When the IO comes back and when the thread is available, it will call the continuation, and so on. So with that model, a single thread can handle many, many concurrent requests. That does scale. This is very, very efficient. It also improves the response time and the concurrency. However, you need to write your code inside the chunks. And how to do that is kind of complicated because you can use callbacks, but nobody really likes callbacks. You can use coroutine in Kotlin, and Quarkus supports coroutines. You can use reactive programming, such as we have in Quarkus with Mutiny, but every time it's a little bit hard for a regular developer and doesn't necessarily make sense for everything. So in Quarkus, we offer you the choice on the same stack. At the bottom, you have this reactive core, and then Quarkus decide if your method that you're calling is reactive or imperative. If it's reactive, then no problem. We will call this endpoint on the IO thread, high efficiency, very few resource used, good response time, perfect. However, if your code is still imperative, because that doesn't make sense to migrate everything to reactive, or because it's CPU intensive or something like that, no problem. Quarkus will still leverage a reactive core, and at the last part, we'll switch to a worker thread. Both models are enabled on the same stack, and even if you switch to worker thread, you will have all the advantage of reactive at the bottom layer, so you will get better concurrency and smaller resource usage. So that's really cool to have the ability to mix both, and you decide where you want to put the cursor. Full reactive doesn't necessarily make sense. Full imperative might be too expensive, so you decide what you want reactive and what you want imperative. But enough talking about that. It's time to see this in action, and we are going to build 5 microservice systems. We will start with VLANs, which will be a simple CRUD microservice exposed as HTTP, where we will just get a random VLAN from a database. Then we will have a super Azure microservice, which will use GraphQL, because GraphQL is very, very nice when you need to adapt data, or when you have data that need to be shaped differently according to the color. We will simulate a fight between VLANs and arrows in the fight microservice, which will be exposed by gRPC, a secured, high performance RPC protocol, which also supports bidirectional streaming. Then we will implement the API gateway, which will orchestrate all the calls. So get a VLAN, get a arrow, simulate the fight, and we'll send this outcome, the fight outcome, on a UI, but also into Kafka, which will trigger an event-driven microservices, which will get us statistics about who is winning the most fight. You can find the whole code on this GitHub repository here, and time for some action now. So let's start. So the first thing you will do is to go to code.quarkus.io and configure your application. So for example, the VLAN service, and select a set of extensions. I picked 3, REST-easy reactive, and REST-easy reactive Jackson. Even if my code is imperative, I can use REST-easy reactive, and it will give me, it will leverage a reactive core, the GDBC driver, and Hibernate ORM, and I could have picked a few others. So to save some time, I already imported that in my IDE, and that's the resulting POM. So I'm using 2.3 of Quarkus. This is Hibernate with Panache, reactive Jackson, GDBCs, and so on. We have a set of VLANs in my database, and that's what represents a VLAN. So a VLAN has a name, other name, level, pictures, powers, and so on. It's a Panache entity, so it's a Hibernate entity, but we have a set of methods already given by Panache, which will let me, well, use count, find all, and so on. So I don't have all the boilerplate, it just works. Also, I don't need getter and setter. I can just have public fields, and that's fine. So let me go there and start this in dev mode. So I do Maven Quarkus dev. So it will start. So that's here. That's the other microservices that are waiting right now. We will do them one by one. So it's starting. Okay. So what you see here is that it's actually starting a database too, because based on the extension I've picked, it said, oh, you need a database. No problem. I'm going to start a database for you. And so now, without having to start anything, I have my database and my application running. So let's have a look at that. I will go there, and I need, oh, that's not the right one. I need to go to 9000. And this is the dev UI. This is your toolbox for your Quarkus application in dev mode. All extensions, or most of the extensions, have a widget that represents them. This is our dependency injections, that's our data sources, Hibernate, REST-easy reactive, and I also enable Swagger UI. So if I go there, I can see my APIs, but hey, I didn't implement it. So let's implement our API. I'm going to use JaxRS here. So I will just do public VLAN get random VLAN. And here's the beauty of Panache. I can just do, and that's it. I saved, I go back here, I refresh, and the dev mode will do that. And boom, I got my VLAN resource with a get. Let's try that, execute, and I get old man. Okay, so that's probably a big super VLAN. I didn't know him. Let's get another one, Atlas, or another one. So it seems to work. Okay, so we got the first microservice. Let's now switch to the second microservice, which is the hero microservice. So same thing. We have a set of superheroes stored not in a database this time. I just have a static file. But a hero is represented like this. It has a name, level, image, powers, and long name. As you can see, it's not exactly the same words that are used here. So the representation in JSON will be slightly different. But no problem, because the hero microservice use GraphQL. So we're not going to expose pure REST, we're going to expose GraphQL. So it's how I did it. You have just your hero API, you use the GraphQL API annotations, and then you have the query annotations that say, hey, this is my random hero. So let's try this now. I'm going to go to QDev. So a second dev UI for that microservice that is already started in dev mode. I can go to GraphQL here, and I'm not very efficient with GraphQL. So the beauty of this is that I can try things like, okay, what if I want the powers, the image, and the level? So I can select the fields of my arrows. So here it picked random, and random has a lot of powers. I don't care about powers in my application, so I can just remove this and do that. Okay, so it removes the powers, so I need the name, the level. Oh, but here I don't want this to be called image. I want this to be called pictures. And that's the beauty of GraphQL. You can write mutation or alias and just like this, and it will name the output. So when I will call that service, that GraphQL service, I can pass that query and it will automatically adapt the model to what I need. So that's cool. It's already good for that second service. It seems to work. We got that working. So let's switch to the third one, which is a gRPC service. So the gRPC service, it's my fight service, which will receive a random hero here, a random villain here, and will organize a fight, and the fight result is just the name of the winner. Nothing very fancy, but so. So this is a proto descriptor of my gRPC service. You don't need to do anything else with Quarkus. You just have your proto file, and all the generation is handled for you. So we handle the generation for you, and you just need to implement the fight service. gRPC is automatically, reactive. It's a distributed protocols, and the model by default is all about being asynchronous and reactive. So what we do here with Quarkus is that we generate this API using Uni, and Uni is part of the reactive programming library we use in Quarkus. So it's part of Mutiny, that's the name of the library. It's an intuitive and event-driven reactive programming library that enables reactive even for non-reactive developer. So what do I need to do now? So I got my request got a villain. Okay, so this is my villain. My request also gets a hero. Oops, request.get hero. Okay, that's my hero. Great. And now I need to make them fight. So I already wrote the simulator of the fight with plenty of random. And a fight takes time, so it's also an asynchronous operation. So I will just do fights. If you want to see how the beauty of my simulator, you can check the code. So I pass the hero, I pass the villain, and it will simulate a fight. This returns a uni of strings with the winner. Okay, great. But what I want here is to return this gRPC object. So if you never use gRPC, gRPC is a lot about using builder pattern. So what I'm doing now is to do fight.newBuilder. Okay. Set winner, my winner, build, and that's it. So how to read this? When the fight, so simulate the fight. When the fight completes, call that method, and this method receives a winner as parameter, so the outcome of my fight, and then transform this into this gRPC response and return that. And that's it. And if you are not completely sure that this is correct, let's have a look at the dev UI again. Oops. No, that's probably 3. Go to the dev UI. I can go to gRPC here. I have the list of gRPC, so that's the health. We are interested by that one. I can test it. We do some mapping between JSON and protobuf, so I'm going to do to do a fight between my two pet rabbits. My first pet rabbit is named Roxanne. She is level 2, and my second one is named Susie, and she's level 2. And believe me, they fight a lot. They don't go along together. I can do send. It's actually really do the gRPC things behind the scenes, so all secured, all binary protocols and so on. So, and because there is some random at some point, yes, so you see Roxanne 1 sometimes it's Susie, and so on. So my gRPC service works, that's cool. So let's switch to the next one, which is my API gateway. So my API gateway need to get a random hero, get a random villain, call the fight service, get the outcome, and send that outcome to expose that outcome as an HTTP response, which will be used by my UI. So my HTTP API here is very simple. It's just a get. Because it's an API gateway that will get a lot of concurrency, it absolutely needs to be fully reactive. So I can't do the imperative trick here. I really want high concurrency and low response time. So it returns a uni again. That's one of the types we support. So I need to call the VLAN service. To do that, I'm using the REST client. The REST client is a way to model your HTTP API using annotation and using an interface, so that avoid having HTTP everywhere in your code base. And again, it's fully reactive thanks to the reactive core of Quarkus. You can also use it in a blocking manner. There is no problem with this. For the hero service, I'm using the dynamic GraphQL client that also returns a uni. So here it's not high level client yet. We are working on that. But basically, I rewrite the same query I wrote in my dev UI, and I'm executed the operation with that query, and I map it to a hero. Everything is fine. So then I go back to my API. Yes, here. And I have the fight service, which is just a gRPC client. So here in my fight method, I get I call my VLANs and heroes. So I got a uni of VLANs, a uni of hero, and when both are done, because I can call them concurrently, so I can combine them. So this is hero, this is villain. Collect all the results in a tuple, and then call the fight service. So to do this, I combine hero, villain, when both operations completed, collect them into a tuple, and then chain the fight operation, because that's what we want. So I got tuple.getList1 is my hero, hero h, okay. Villain v equals tuple.get the second item. So this reuse the same order as I passed my uni here. And then I need to invoke the fight service. So I will show you this method. It's just to save some time. And I just need to return this. And that's it. So invoke fight service is just calling my fight service gRPC client. And again, it's used all these gRPC builders and so on. So that's it. I just need to return that and I'm done. So get a villain, get a hero concurrently. When both are done, accumulate them in a tuple and then change them to invoke the fight service and return that. So now if I go there and I will open another tab, localhost, no, it's 9999, okay. This is my cool UI, so I can click on fight and it's pick both, and so the winner is the villains here, and the winner again the villain. Oh no, it's the word girl that won. So let's stay on this. So what I wanted to do too is to send that outcome to Kafka. So to do this, I use emitter. An emitter is an object that will send a message to a channel, and here we want to send the fight outcome to the fight channel. So I'm going to do that here. Let's call my emitter. Emitter.send fight, and that's it. So here I chain. So I want to call another asynchronous operation and return the result. Call is a little bit different. It gets the result, so the fight, but just want to do some side effect without modifying that file. So when emitter.send completes, because that's also an asynchronous operation, we need to write to Kafka, this is asynchronous, it will return the same file, it will return the input. So the return here still returns the file, but at the same time, we have sent it to Kafka. So let's try this. I will go back here. Every time it sends the message to Kafka. So that's pretty cool. It's already sending a few of them, but we want to see this. So what I'm going to do now is to show you the stat service. Where is that? The stat service is here. Here. And the file processor read from file channels and compute some ratio, so who won the most between heroes and villains, and broadcast that to a REST endpoint, which serves that as an SSC. So if I go back here and I do, yes, that one, and I will go back to my UI here and do this, okay, oh, yeah, better. And now you see that every time I trigger a fight, I get a message here because it sent it to Kafka, the stat service is triggered and can compute the stats and send those stats here. So we got 4 fights, hero 1, 2, villains 1, 2. One thing that is very important when we do such kind of system is to protect ourselves against failure, because as I said, failure are inevitable on any distributed system. So to do that, you can just use a few annotations, like let me retry this one, max retry 5 times, and between each retry, wait for 1 second, something like that. Or let's also add a timeout, which will be, let's say, 2 seconds, or something like that. And you can use this annotation on imperative and reactive APIs anywhere inside your application, inside your beans. So for example, I can go there and do the same thing here, like that. I can use fallbacks, I can use, let's change that and use a circuit breaker here. And maybe for this VLAN service, I also want a circuit breaker. Whatever you want, you can have fallbacks and so on. And automatically, now this gets protected. So now when I do a fight, if something wrong happens, I get fault tolerance that kicks in, we try, do all its work, and use fallbacks, and so on, and so on, and so on. So very easy to protect yourself against well, remote failures and bad things that can happen. So let's go back to the slide and conclude. Okay, where is that? Here. Oops, sorry. So we already scratched the surface of Quarkus. What we have seen is that in a few minutes you can build a multi-microservice systems using gRPC, Kafka, REST, GraphQL, and an API gateway, a fully reactive API gateway. You can also write regular CRUD applications, monoliths, event-driven application, reactive systems, so better distributed systems, functions, command line, administration tools, and so on. So there is a lot of possibilities to let you build your next system. If you want to go further, I recommend these 2 books. The first one on the left side is Quarkus for Spring Developer from Eric De Andrea. It's available from free from Red Hat Developer. It's a small booklet that will explain how to switch from Spring to Quarkus, what are the advantages, how different it is. Strongly recommended. The second one is a shameless plug. It's Reactive Systems in Java from myself and Ken Finnegan. It goes a lot deeper on the reactive side of Quarkus, how to build better distributed systems, how to build messaging, event-driven architectures with Quarkus. It will be published in November 2021, so it's a perfect Christmas gift for your whole families, children, spouse, husband, parents. Well, it fits everyone. Anyway, I'm going to conclude on this. Thank you very much for attending this talk. If you want to start, go to code.quarkus.io, select your extensions. The 4 next links are the guides of everything I've used today. So gRPC, GraphQL, and Hibernate, ORM with Panache, and Kafka, sorry, too. And finally, you can follow us on Quarkus. And now, if you have any questions, I have a few minutes to answer them. And how does that work now? I may stop sharing.
Clement, your questions are in the chat window.
All right, thank you. So I stopped sharing, so you probably just see me, but let's do this. So in your opinion, what are the best use cases to use reactive programming style? Should always be on top option of developers? No. Reactive is only required when you need high concurrency, when you need to use your resources efficiently. Don't try to do a from scratch end-to-end reactive application. This is a big difference on how you write, how you think about your system, so definitely don't go there. Quarkus offers both possibilities, and you put the cursor where you want. Traditional transaction CPU intensive, stay imperative, that's fine. Already the reactive core of Quarkus will bring you better performance, better efficiency. If you really want highest concurrency, if you are really a lot of IOs need a bit more concurrency or even a lot more concurrency, then yes, reactive is where you need to go. So yeah, it's really, you decide. And don't forget, on Quarkus, you can have both side by side inside the same application. So typically, if you have a large application, some CPU intensive, transaction aware thing, okay, stay imperative. And you have a few REST endpoints that are really hammered a lot by your customers, but don't need all this, or just do some access to a database, but nothing much. Well, then switch to reactive only for this. You will have lots of advantages on just migrating this or only this. So yeah, decide where you want to put your cursor. Try and see. Oh, and in the dev UI, you can actually score your endpoint, and it will tell you how reactive you are and if it's acceptable for you or not. So you are imperative, okay, not great, but do you need to improve or not? That's up to you. So where do I get the demo applications? It's on a GitHub repository. So let me share quickly my screen. Yep, share. Hopefully you see it. We'll go back to my slides. Hey, where are my slides? Here, okay. And it was here. So you go to this GitHub repository. You have all the instructions to run that system. Well, it's already fully developed, so you don't have to do the code, but you can. It will explain you, or you start your microservices in dev mode, and so on. So it's already there, and feel free to play with it. And yeah, and well, play with it. You will see. Add some stuff if you want, or change a technology. Like, oh, you're not a big fan of gRPC. You prefer having, I don't know, another REST service. You can do that, or whatever you want. Or don't like Kafka, prefer MQP. You can do that too. And do I have another question? One. Okay, so perfect. It seems that I'm going to stop sharing again. And it seems that we are just in time. If we don't have any more questions, we will stop here. And again, you can follow us on Twitter. You can go on the Quarkus GitHub repository and click on the star button. That's completely useless, but that makes us, the Quarkus developer, quite happy because we get more stars. And yeah, and I hope you enjoyed that talk.